All right, hello everybody. We're about to get started with our next panel. We'll be talking about FHE readiness, the State of the Union, and all things related. So I'd like to welcome the speakers up. Is this thing working? Is it working? Okay, so let's start off with a quick round of introductions. You guys tell me who you are, what you're working on, how does it relate to FHE, and in a one-word answer, is FHE ready today?
Okay, sure. Hello, I am Joseph Wilson. I am the head of strategic innovation at Optalysys. If you've seen our stand out in the other room, you'll know that we are working on hardware acceleration for FHE, the first product with an emphasis on the blockchain. And in one word, is FHE ready? Yes.
Hi, everybody. I'm Jonathan Alexander. I'm CTO at OpenZeppelin, and we work on open source tools for developers and builders, and we provide security review and audits. And I'm going to say that my one word will be close.
It's not an option, but we'll take it.
If it's not close, I'm going to say no, and I'll be controversial. Yes.
Perfect. I will challenge you gravely on it. Hey folks, I'm Guy Tzchaki. I'm the CEO of Fhenix. We're providing FHE as an infrastructure for developers to provide smart confidential contracts on Ethereum. In addition to that, I'm a Liverpool fan. If you just want to know more about me, you're more than happy to jam with me outside about FHE and everything else. And my short answer is not yes, and it's no, it's definitely. I am a great believer in FHE. I know it's more than one word. You may want to follow up with me after that in a minute.
I think so. Let's first backtrack a little bit. What does FHE readiness even mean? What are we getting ready for, and what does it entail?
Okay, I'll go first. So to my mind, readiness means it's in a business context, and it means that you could potentially start to run a service in Anger on top of it that does something useful in a way that you couldn't do before. Now, the reason why I think there's probably going to be some contention here is because when you say, oh, you could use it for something, what are you using it for? The question of what you're using FHE for is kind of like asking how long is a piece of string? Like, can you run a complete encrypted LLM under FHE? No. Could you start to address business value with FHE? I think yes, even at this stage in the game. So that, to my mind, is readiness.
Joe, could you give us some examples?
Yeah, so obviously we focus on encrypted ERC20 transactions. Like, the product we're developing is targeted towards that ecosystem. We know there are partners out there. We know there are people building on top of this. And the actual stack, the ecosystem that you would need to enable this is starting to come together very strongly. So I think all the pieces are on the board. It's a question of actually making sure everything gets into the right place and you can start to deliver that value. But it doesn't mean that the ecosystem isn't ready for that.
Yeah, so I want to walk you through like a really brief journey of my love affair with FHE, which started about 2017. First time I've heard of it, sounded like magic. I said, like, what is this crazy thing that enables you to compute on data while the data is encrypted? And like, it's like these technologies that you keep on hearing, fusion reaction, stuff that you keep on hearing, and you always say it's like, you know, it's in the distant future. It will never going to happen. But there's actually been a lot of progression in the last couple of years of FHE. And you can see here a bunch of interesting characters. We have an FHE hardware provider. We have OpenZeppelin that are going to tell us more about what they're doing with FHE. And we have us that are taking it into the blockchain space. The state of the union today is that it's definitely ready for specific use cases. We will not use it for real-time application or high-volume trading. But hey, homomorphic encryption is being used by Apple today. Like, if you don't know that, you're more than happy to go and Google it. They've announced it a few weeks ago. It's being used by the Microsoft browser as well. So there's definitely applications in real time that are using homomorphic encryption. When we talk about what does it mean to be ready, I would say it's two things. A, it's simplicity. We all need to make sure that it's very simple to use. And for those of you who are in the morning session and you saw Tom's demo of Redact, it's like literally you don't even know what's going on behind the scene. Nobody cares about it. And it works really, really well. So one is simplicity. And the other one is performance, making sure that it's working fast. We can untangle this for quite a lot about schemes and hardware. But I would say for many applications, definitely ready.
Yeah, and I think those answers just highlight probably our answer to the first question was just that there's a different spectrum of what we call readiness. And when I was saying close, I think in terms of mass adoption and real world usage, there are things that we need for toolkits, developer tools, testing, platform readiness, platform robustness. And I actually think saying that it is close is actually tremendously exciting, because the technology itself, I agree with both of your answers, that the technology is working and proving and has just, we see the tremendous capability here. And there are now multiple people working together on the full readiness for what is going to be potentially, a huge opportunity for adoption. And so we're very close. And so it's all really exciting, and somewhere in the spectrum of, yes, it's all working because certain pieces are, and yes, these other things are coming together for developers and things. We're just about there.
Yeah, John, I want to come back to something you said there about dev tooling being a critical missing piece and something super important in the process. What do you think that looks like? What are we missing? What's the ideal setup for the developer FHE stack?
Well, so it's really important for a lot of the initial applications that we expect. There's a lot of opportunities for financial applications and asset tokenization and payments. These are things that involve interoperability. We need them to work on existing systems that are also already being widely accepted and adopted. We need to be able to have the things that we're going to want to integrate for regulatory compliance, and we're going to need interoperability with existing systems, because if everything's on an island, that's not what everybody's coming for. Interoperability in these better Rails 24/7 markets. And so what we need is kind of standard interfaces and definitions that will work together with other things. And we also need the developer toolkits and capabilities that'll easily integrate these into the wallets and applications that already exist. So one of the things that we're working with Fhenix on and other partners is OpenZeppelin, as an example, will soon be putting forward a new ERC standard with multiple partners to define kind of the first fungible token interface that incorporates FHE. And the design there is meant to promote common interfaces. The reason why we have common interfaces is so then we can build wallet interfaces and developer tooling, and people can take advantage of them and have confidence that they'll work with the underlying technologies. So those are examples, kind of the standards at the smart contract level, the SDKs and the toolkits for the wallets. Those are some of the things that I think about when we talk about the things that need to be there. Yeah.
Yeah, absolutely. Thank you so much. I think interoperability, that's a great point that honestly needs to be discussed. So where do we see FHE enabled contracts, or this, this developer stack that you're describing now? How is it interoperable within the wider Ethereum ecosystem and on a contract to contract level?
I think there's definitely more one for you.
More me. Yeah. I don't want to do all the talking here, but sorry. I think that the great thing about the technology and also the implementations that many of the teams are working on is that it is very easy to make it. It's very possible to make it interoperable right into existing Solidity. And that's one of the really exciting things here. And I think that's one of the most promising reasons that we can drive usage and adoption very quickly. And so that's kind of the primary thing I'll say, the details of which I won't get into right now. There are things that people can see that are already posted in the OpenZeppelin GitHub. Look at our confidential contracts repo where things are being posted there. That's a preview of some of the things that are coming, and you'll see.
Okay, yeah, sure. So I have my own perspective on this, and I think I'm going to come at it from a slightly different angle, coming from very much the bottom up. in FHE, because this is very much top down in terms of the FHE sort of like blockchain ecosystem. I will agree wholeheartedly that the Solidity integration is extremely powerful. That kind of connects the top level developer to the whole sort of like stack of things that sits underneath that, and I think that's absolutely essential for the growth of the ecosystem. Looking further down the stack, in terms of developer tooling to enable greater flexibility, to make the ecosystem less brittle in terms of like you've got hardware, you've got like a very specific crypto library and a very specific Solidity implementation. FHE is a very fundamental technology that I think is going to have much broader applicability, and part of the ecosystem beneath that I think is going to really help at the top level is actually things like compiler infrastructure for FHE, so being able to generate performant FHE circuits that will be applicable for, yes, blockchain, but also, you know, AI and so on and so forth, in much the same way that the unencrypted compute stack at the moment is very, very flexible, very, very powerful, enables us to build all sorts of things on top of that.
It's also important to understand that as a developer, there are two different verticals to consider. One is just the ability to use FHE. And it's very easy. You import the smart contract, you encrypt, decrypt. So the mechanics are, I would say, extremely easy. But, and that's an important but, when you start working on encrypted data, the entire state of mind need to be different. It's no longer how you operate on regular data. You can't assume that all I'm doing as a developer is just encrypting the assets. You need to change the design patterns. You need to think differently. That adds complexity, and we cannot like put it aside. So there is definitely complexity associated with it. My personal opinion, I see it within the team, and I think we all see it, is that the progression that we're seeing today, this transformational phase where people are starting to use AI tools to build code, it's no longer, you know, you build it from scratch. It's like 80% you get it already automatically. As these mechanics become more and more sophisticated, they will enable a big portion, they'll reduce a big portion of the complexity. We will always have the need for somebody who like really understands the privacy aspect, but things are just getting faster and better. But I say, as of today, mechanics very, very easily. There needs to be a different state of mind when you start operating over encrypted data.
Question for you, Joe. So we understand hardware acceleration does rely on hardware, of course. What are some of the trust assumptions associated with that, or some of the things that developers might be concerned about?
I mean, in terms of what we do specifically in the ecosystem, you can think of an FHE hardware accelerator like ours as effectively being like a very big fancy calculator. We don't ingest any kind of secret information into that system. It's not a HSM. It is purely a system for ripping through a stack of FHE instructions as fast as possible. Now, I do know at the protocol level, obviously, you have to solve things like how do I do threshold decryption? How do I do key management? At the hardware level, like, this is still somewhat unusual. Like, if you think about any kind of computing system beforehand, you always had to consider things like attacks in the side channel. So not just about like the vulnerability of software, but the vulnerability of things like emissions from the system, electromagnetic, thermal, noise, things like that. If the system is never handling sensitive data directly, it's never handling a secret key, it's not handling any unencrypted data, you have for the first time a modality of computing that is actually almost totally resistant to that, outside of a few assumptions about things like reaction attacks, for example.
So if I'm new to that space, I hear TEs, specialized hardware, and we need specialized hardware for FHE. Can you maybe explain the key differences and why not go with a TEE?
Sure. I mean, the TEE is based on sort of overlapping assumptions about security, but it's not unified. Under FHE, all your problems of, is this secured against side channels? Is the attestation stack secure? Can people, you know, falsely sign these things? All of that reduces down to a question of key management. Do I know where my keys are? Are they in my possession? Are they, you know, elsewhere or what have you? If I can be sure as to where my key is and the security of that key, I can be, you know, sure of the security of my data outside of my org as well. And that's something very, very different in terms of, I guess, the trust assumptions that you have to make regarding these things. But TEEs have been demonstrated to be broken. I don't know if you guys saw like the bad RAM attack that Leuven put forwards, where somebody broke AMD 7 on an FPGA with like $10 worth of hardware. Like, that's what we're talking about. We know that TEs have vulnerabilities. They're a great addition to this space, and TE-like principles are very core to FHE as well. Like, can you attest to the computation? Can you attest to the code that is running on there? These are not things that you're going to fully replace just by going to FHE. There is more to it at the protocol level. But I think it is really important to distinguish in terms of the security where that distinction lies between TEs and FHE.
Yeah, I would love to open that question up to both Guy and John. What susceptibility or what vulnerabilities are your techs susceptible to? What are the main vulnerabilities that we're most concerned about? Or what are you thinking, you know, along the lines of just FHE readiness when it comes to attacks?
So in FHE space, you have operating over encrypted data, and you have the decryption part, which is the key that enables decrypting the content. Protecting that key is key. The way we're using it today, and the way that many others are using, is that there is actually no one key that can decrypt all the data, but rather we use a threshold decryption kind of solution, which is a mix of MPC and FHE, so use secret shares, and making sure that this operates in a way that does not enable collusion over one single key that can decrypt is the main thing. We have a decryption protocol that we are utilizing, but as anything else, you need to make sure that it's either your key or the key that maintains the network is never held in one single place, that it's split among different players, which is, I think, what we're doing today. So that's on the decryption part of it.
Yeah, I'm not a cryptography expert, so I'm going to say this without the deep background of my co-panelists here, but OpenZeppelin is a well-known auditor in the security space, and one of the things that I think is most promising and exciting about FHE is I believe the security attack surface is much smaller than every other serious technology we're looking at for confidentiality. I will say, on the other hand, I do want to say that there are different application areas where certain confidentiality technologies may excel, but FHE has some really exciting and very, very important opportunities, and this smaller attack surface, I think, is one of its key benefits.
So I think we should backtrack a little bit. I know we've talked a lot about the future of FHE, FHE at current, but FHE's been around for a really long time. What has prevented us from being ready until now?
I guess it takes quite a long time to go from IACR white paper to like something I can do on my phone. I think there's a natural progression to that, and if you look at the history of cryptography, you look at how long it took between things like RSA being developed in the 70s to where that became something that was, there by default, cryptography in the browser. I think you always have to go through a period of cryptanalysis just to make sure that what is being proposed is genuinely secure. So if you look at what NIST were doing with the PQC standardization, that took them years because they were trying their best to break every candidate they saw, and they did break several candidates in that process. And that is just something where you have to have a lot of time and a lot of attention. Now, FHE also has this very unique property that you can compute on that data. So there is also a process of understanding like the raw computational side of FHE. How do you optimize that? How do you integrate that into the existing computing stack? You've got the protocol side of things. So this is why, this particular sector in blockchain is so exciting, because you've got the people who will genuinely get up to the elbows in the protocol, do the, the very sort of like difficult work of actually making a product out of that, and that again takes time.
And maybe a different point of view is to not so much understand the progression, but what are the signals that we have today that we've reached this phase. And I think some of the signals is actually the fact that we have here a hardware company, we have here OpenZeppelin that are starting to build solutions for developers, we have end user applications. One of the things that we are now working on is a confidential stablecoin. Again, you saw the way Redact works, and there are products that are building confidential lending, Silhouette, and a few others. So the fact that we see this ecosystem maturity of both bottom-up, hardware, developer tooling, infrastructure, and then applications that are starting to build are really strong signals that we've reached this point that it is already ready and mature.
The question was, what has been standing in the way all this time? I'm again kind of more of the novice here and the newcomer in terms of OpenZeppelin coming to work with FHE. My understanding, and repeatedly it's the question we hear come up, was always kind of performance and cost. Those are the basics. Again, the experts tell me that the math is really complicated, and it's so, but that's what's so exciting, is that there seem to have been just order of magnitude jumps, and now we're at the point where performance is acceptable and cost is acceptable, and now also we have the other things where we have the needs. So yeah, but that's my understanding from what I've heard, yeah.
Out of curiosity, like if people had to guess, an addition, right? If you want to do an addition operation, adding to encrypted numbers over FHE, how long would it take? Minutes? Seconds?
Quick show of hands, how many think it would be around the 5-minute mark? Less?
Okay.
More?
We're not at the 5 minute, but like I would say 10 seconds. Does that 10 seconds sounds about right? Okay, one hand, maybe 2 seconds. Yeah. I think we're about 100 millisecond. So like this entire shenanigan of FHE being too slow, yes, there are very complex operations that may take more than that, but in general, we're talking here about milliseconds, and that's roughly the range.
Yeah, and in terms of like, and obviously we're looking at different technologies, but we're looking at things like gas cost on Solidity, EVM, and it's getting into a completely acceptable range for the compute time is acceptable, the gas cost is acceptable. Again, you have to look at use cases, but would somebody pay, a tenth of a cent on big L2 right now to add FHE and do addition? It certainly seems that we are in an affordable range now. And we only see more improvements coming, and that's what's exciting about some of the hardware work and things like that. Yeah.
All right, so one last question for you guys. If you had a magic wand today, you could wave it, anything in FHE would be changed or fixed. What are we doing? Guy, we'll start with you.
Anything in FHE that would be fixed. I think from a technology standpoint, we're pretty okay. I would definitely love to see better performance, even faster than that, because for me, the high volume trading is something which is really exciting. I know of work happening, again, in the hardware and software front, so that for me is something that needs to happen from a performance, continuous improvement. But for me, a lot of it is not so much about FHE as a technology, it's about the privacy perception. I think it's getting better and better, and I'm really excited to see the Ethereum Foundation speaking a lot more about FHE and ZK, so for me that's like a really good sign. But I would want us to all understand that this is no longer like a nice to have capability. This is something that is fundamental and will come in the next 6 to 12 months.
Yeah, I think for me, if I could wave the magic wand in terms of the scope of what FHE can achieve across the FHE ecosystem, I think this is quite relevant to Fhenix as well and the way you guys are going about things. I think if I could wave the magic wand, I would put us forwards in compiler technology by a year, because there isn't a lot of very impressive work going on in the FHE compiler space. And I think the ability to maybe lower from high level sort of like mathematical descriptions in terms of the cryptography to like composable polynomial level operations and exchange between those, I think you could gain a lot of ground in terms of being able to support different SLAs for things like HFT. If you wanted to go from like, here is a smart contract definition, and maybe express that in terms of different or more efficient FHE operations and support that SLA better. So that's where I would wave the wand.
If I could wave a wand, I would do one of those memory erase. If I had some kind of memory erase that I think, for some reason, I don't know why the last few years, there's been a lot of conversation that seems to somehow pit FHE versus ZK, and I would erase everybody's memory on that. Because I think at OpenZeppelin, we see I think that what we're headed for is a world where both will be used, and they both are have incredible promise, and they have different application areas. And I don't know why everybody kind of got in this, like, it's this versus that. Maybe we blame the mathematicians and the cryptographers a little for that. I don't know. But anyway, I think that people should be looking hard at FHE because it's here and it has some really important application areas, and also ZK. And don't think that it's one or the other. Understand both, and let's understand that both of these are going to move Ethereum forward. So.
All right, that's a wrap. Thank you guys so much for joining me. A round of applause for our panelists.